hill and you're faced with the option of stopping a runaway semi-truck or stopping a runaway bicycle, you'd probably choose to stop the bike, right? The reasoning behind this is that the semi-truck has more momentum than the bike. Momentum simply means mass in motion. The semi-truck has a large momentum because it is very massive, but it also has a large speed, which influences momentum as well. The bike also has momentum because it has a large speed, but because its mass is less than that of the truck, its momentum is also less. This relationship can be described in an equation. Momentum equals mass times velocity. You may remember that velocity is speed with direction, so if an object has a large speed, it also has a large velocity. Our momentum equation can be simplified even more by substituting the words for symbols. P equals mv, where P is momentum, m is mass in kilograms, and v is velocity in meters per second. As you can see, if you increase one of the variables on the right side of the equation, either the mass or the velocity, the momentum on the left side must also go up in order to keep both sides equal. If you increase both mass and velocity, the momentum goes up even more. In this way, we can see that both the bike and the semi have a large momentum, but the semi is still more because it is far more massive than the bike. This also means that an object at rest does not have momentum. The velocity of an object at rest is 0, so there's no movement. In order for an object to have momentum, it must be moving. An important thing to note about momentum is that it is a vector quantity. This means that it has both magnitude and direction. Velocity is also a vector quantity because it has both of these components, and fortunately for us, the direction of the momentum is the same as the direction of the velocity vector. But in order to fully describe the momentum of an object, you must include its direction. Otherwise, it's not a vector. As you now know, an object of any size can have a large momentum because it depends on the speed of the object as well as its mass. A supertanker ship that is coming into port may not be traveling very fast through the water, but it is quite massive, so it needs to begin slowing down long before it gets to port in order to be able to dock safely. Let's say that our bike speeding down the hill is 1/2 of the semi-truck's mass, but is traveling twice as fast. In this situation, each vehicle has the same momentum. That may sound a bit far-fetched, so let's look at it in the equation. For the truck, the momentum is P equals 2m times v. The bike's momentum is P equals m times 2v. Can you see how this would equal the same momentum for both vehicles? As long as you know the mass and velocity of the object, you can determine its momentum. A 5-kilogram ball rolling at 10 meters per second to the right has a momentum of 5 kilograms times 10 meters per second, or 50 kilogram times meters per second to the right. If that same ball increases its speed to 20 meters per second, we simply double the momentum since the velocity component is doubled. The new momentum for this ball is 100 kilograms times meters per second. Because the momentum increases or decreases by the same amount as either the mass or velocity, we say that they are proportional. All this means is that as one variable changes, the variable on the other side of the equation changes by the same amount. Knowing that they are proportional helps us understand why the bike and the semi can both have the same momentum under the right conditions. Momentum is mass in motion and only applies to objects in motion. It's a term that describes a relationship between the mass and velocity of an object, and we can see this when it is written in equation form, P equals mv, where P is momentum, m is mass in kilograms, and v is velocity in meters per second. Because momentum is a vector quantity, this means it has both magnitude and direction. The direction of the momentum will be in the same direction as the velocity, but it needs to be included in the description of the object's momentum in order for it to be fully described. Momentum is proportional to mass and velocity, meaning that as one of the variables changes, the variable on the other side of the equation changes by the same amount. Double the mass and you double the momentum. Triple the velocity and you've just tripled the momentum. But double both the mass and the velocity and you quadruple the momentum because both variables have increased, affecting the momentum of the moving object.